Correct.
What is the importance of this interface and API design? Why is important?
Uh, Interface, well, I don't know in the context, I'm not understanding, but anyway, I've heard the term and I've used the term. But API, yes, for example, API is nothing but a small routine which which can be used by, which can be called by many applications. A very simple example. In fact, when I was developing the ERP application for a small company, so the I had written a very small 4 lines procedure like in Oracle. Okay, so let's say we have around 15 to 20 screens. In all those screens, the first input, the basic input is a item code. So the moment you enter the item code, you should go to item master, pick up all the relevant master details. For example, its description, part number, unit of measurement, maybe the stock details, all that information it has to pick up and then display in a small pop-up window. This requirement was there in almost 10 to 15 screens. So I wrote a small common routine, okay, and converted to, for example, exe file, and then call that wherever required without any change. Just the input is only the item code, unique item code is a primary key. Provide that, and it will get the display. It will display all the data. So that, in fact, is an API for me. So, for example, even in payroll, somewhere in payroll, we wanted the components used by that so and so person. Or when he was resigning, we want to display all the components used by that person. So just give the item code; it will display the entire details for him. So in this way, API had designed, but now it's called as API. But earlier, I just called it as a common procedure, which can be used, which can be called from any of my programs. So in the same manner, I think today what we're talking about API is nothing but a routine which can be called upon and which may or may not give any output. Generally, it will give some output which we can capture and then display in the front end screen.
So yes, basically API as its name suggests and full form, application programming
interface. Okay.
Okay, so
Okay.
interface is you can think of your ATM, how you can interact with the you can say interface,
Right.
which option you need to choose.
Right.
So you can interact with your system,
Right.
am I right, or
Right.
application.
Right.
So that's are required, am I
Right.
right?
Right.
Like you told me, you explained very well. Means in their user need to send that primary key.
Yes.
Then he is able to get that response.
Yes.
Am I
Yes.
right?
Yes.
So those things we need to consider in our API design or this interface design. What is the input and how will process and what is the output and how will behave.
Correct.
We not means discuss about table and things. We are discuss about the designing, which
Right.
thing we need to consider it, which we what are the other options are there. Okay.
Right.
So first thing first, we need to discuss about this strong versus eventual consistency. You know, consistency we discussed so many times.
Yes.
So what is that, and what do you understand from this strong versus eventual consistency? Hello.
1 minute. Let me. I'm just thinking. Okay, I mean, as explained, okay, like in our online boutique example, at any point of time, all the users should be able to see the latest stock details in our inventory. Whether is logging in from India or any other part of the world, at the same time, when they're logging, 100 people logging at the same time, they should be able to see the same stock condition. So that is the consistency we are talking about. But anyway, here something called strong has come, one keyword, extra keyword, and also eventual. See, eventual consistency in a general term, I'm thinking the moment a order is executed, eventually the stock has to get updated. So temporarily, maybe for a few microseconds, it will be updating the latest stock, and then it will bring up the latest stock details. So otherwise, I'm not having much understanding on the strong keyword and the eventual keyword.
So strong as suggests it should be means consistent.
Ah,
We cannot compromise with the consistency.
ah,
But eventually we can, you can say, give a tolerate some time.
Fine. Okay.
You understand my point?
Okay.
So we can give us some time.
Ah,
That's not an issue. It's not critical.
ah, ah,
But
ah.
in a strong, we cannot give a time.
Oh,
We
okay.
need a instant.
Instantly it is updated. Okay.
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 So like your this payment part,
Payment part, correct.
am I right?
Yes.
If means something is updated, it
Mm,
need to
mm.
be reflected.
Yeah, correct.
Need to be reflected same status to
Yes,
all the users,
correct.
all the actors. Am I
Right.
right? And eventually you can think of like uh, like our dashboard and
Mm.
analytics data,
Ha, ha, ha.
okay, which we are using for our own purpose. If
Mm, mm,
there is some delay, that's fine.
mm, mm, mm,
But in our payment and things, if there is a means inconsistency, user is means one user is able to see
mm,
payment is done, another one is showing processing only.
mm, mm.
You understand my point?
Yeah, yeah, yeah.
So which cannot be tolerated. So based on that, we need
Mm,
to take care of these things.
mm, 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 mm,
Means for both the things, we
mm.
need to take care means time. Okay,
Correct.
and means how much time we can consider for a eventual consistency.
Mm,
Okay,
mm.
and we can tolerate which data, which processes work for consistent,
Okay.
strong, and for eventually.
Okay.
Okay,
Right.
like as here we are able to see where money order confirmation, inventory, and critical state transaction
Yeah.
go with the this strong.
Strong consultancy. Correct.
And wherever we need to, you can say this tracking, analytics, notification,
Mm,
this which is you can say tolerate this.
mm, mm, mm.
Then we will go for a eventual one.
Right. Right.
So here these are the visual diagram.
Okay.
Okay, strong consistency means right order paid.
Right. Ah.
Okay, so primary database updated and it should be reflected
Reflected immediately. Yes.
for both the users.
Ah. Yes.
If client A is reading, then it should be reflected same
Ah.
output. If C is reading, then it means give a same output.
Right.
And here, an eventual consistency means if means you order a thing and then means updated a information of rider or you can say then you can say think of user A is able to see its reach data you can say
Ah.
this roundabout but C is reflecting other way, which is
Correct.
okay because
Yeah.
there is
It's okay.
no
Yes. Yes. Yes.
yes we can tolerate there.
We can tolerate this. Correct.
Okay, so this is a strong and conceptual this
Right. Right.
consistency.
Right.
Okay.
Right.
So now handling concurrent updates.
Ah.
Okay. What do you understand from concurrency?
Like now there are 10 users at the very same second they have logged in, and they're all placing the orders. So so I mean, that is called as that more than one user doing the operations is the same operation is called as the concurrent operations.
Yes, so basically here we're talking about concurrence is fine. Here
Hmm.
we're talking about update.
Ah,
You understand my point?
ah.
So what you understand from update?
That is, I'm modifying or changing the example. The moment order is placed, the quantity has to be reduced. So that quantity has to get updated with the for example, -1. That is, one order is placed by one customer. The quantity has to be stock item has to be updated by -1. So that is called as the so in the same manner, like in the same manner, many users have logged in, many users are placing the order. Concurrently, it has to go and update that column called the stock item, stock quantity.
Yes, so basically there is only one thing.
Ah,
Okay, and means multiple actor can act on that.
ah.
You can think of.
Mm,
Means we have only, you can say, last means idli dosa plate is there,
mm,
and many person are
ah,
trying to book. Am I
ah,
right?
ah.
So based on the, you can say, they will request, hey, we require a idli dosa, but who paid first?
Mm,
Then that's closed, no
mm.
more available.
Yeah,
Am I right?
yes.
It cannot be, you can say, display a thing means, hey, this is still open. No.
Mm,
You understand my point?
right.
So here you are able to see how it will work.
Mm,
So here means this is like in a food delivery or this grocery item app.
mm.
They have a multiple riders or delivery persons are
Okay.
there. Am I right?
Yes.
So delivery partners are there.
Ah,
So they will broadcast for you can say, hey, this is a order.
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 Yes.
And but whomever nearby available
Yes.
who have a chance to accept that order. You understand my point?
Yes.
So let's say first accept partner one accepted
Yeah.
or Raju is accepted that order,
Yeah.
and then you can say John is also accepted that order.
Right.
Okay.
Right.
So we are checking the availability and checking the status
Yes.
and assign to a P1,
Right.
updated P1. Then another request, same time, another request comes for you can say John, and
Mm.
we will done that. Am I
Yes.
right?
Yes.
So in that manner, we are saying last wins.
Mm.
Okay, first one is ignored and last one wins.
Mm.
Okay, this is a concurrent update conflict.
Okay.
Okay,
Okay.
you understand the point?
One minute, Deepak, 1 minute. So now here, uh, example, you're given two partners, you're given one order API and then one database. Okay, now, so accept the order from these two partners, and then it hits the order API, accepted the order. Fine. Next, what it happens is check order status. It's available. Second partner's order status available. Update assigned partner. Update assigned partner. Okay, update for P1. Then assigned partner P2. Then last the conflict or last right wins risk. 1 minute conflict or last right wins risk. Uh, can you please elaborate a little more on that, Deepak?
Like means right now
Ah,
means as per the record
ah,
means last is updated.
okay.
Last means in a record last person
Ah,
who claimed pattern 2 is there.
ah, ah, ah,
Am I right?
ah.
So as per the record, even he or she win. Am I
Okay,
right?
okay,
So we will go with that only.
okay.
You
Oh,
understand my point?
last right wins. Okay, got it. Okay, fine.
Okay.
Right.
Because we give her this provision. So based on that, last wins.
Correct. Yes.
Because last is updated one. Am I
Correct.
right?
Correct.
So there is a to avoid this conflict,
Hmm.
we have this. safe conditional update.
Okay.
Okay, in a safe conditional update, we will check the condition first.
Ah.
Okay.
Hmm.
If condition is means fulfill,
Hmm.
if not fulfill, then we will give a chance to a second partner.
Second. Okay. Okay.
Otherwise, we will reject. You understand my point?
Yeah. Okay. 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 So
Okay.
update orders set partner P1 waste that is available, correct. Then say it is success, find accepted. Other look then our update order set partner P2 while status available. Then 0 rows updated. 1 minute. So now yeah, okay. Then again accepted. Then orders okay. They are already assigned to somebody to partner 2. Okay. 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 Okay.
Okay.
Okay. Okay. Deepak, okay.
So now we talk about optimistic concurrency control.
Right.
So what do you understand from optimistic?
That is very sure of very sure of updates, very sure of the consistency of the data. That's called optimistic.
Okay.
Oh, here is different. Okay, optimistic concurrency allows updates only if the record has not changed since it was last read. Optimistic concurrency. Okay, optimistic concurrency allows updates if only if the record has not changed since it was last read. Okay.
So let's say you are trying to update
Hmm.
the things and you check that it's not updated.
Hmm.
Uh, Whatever you are able to get is data is still there
Hmm.
and it's not updated. Then you go for update and with a log. Okay.
Okay.
Okay, and when it's done, then you will update the, you can say, version or counter there.
Hmm. 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 Hmm.
You understand my point?
Hmm.
So here you can say this. What is the advantage of this?
Hmm.
And where you require that,
Hmm.
where user have a many, you can say this read operation,
Read operations. Okay. Okay.
and fewer write collisions are there,
Yes.
and high throughput needed.
Hmm.
You understand my point?
Okay. 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 Okay.
If avoid heavy logging and work well when conflicts are there.
Hmm. 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 Okay.
Okay,
Okay. Avoids heavy locking and works well when conflicts are rare. Okay. Okay. Fine.
so here you can say when two actors are trying to update the same
Hmm.
order
Hmm. Hmm.
and the correct latest version succeed.
Right.
So this is a diagram. You can
Hmm.
check that.
Hmm. Hmm. Okay. So fine. Then yes, the commission. Otherwise, no. Okay. To 5. Yes. Okay.
How you can think of regarding this?
Pessimistic thinking locking.
Hmm. Means how it will work. This flow diagram. What you
1 minute.
think in
See,
a
read orders. Okay. Read order version 5. Okay. Client modifies the data. Send update with expected version 5. Okay. The current version still 5. Yeah. If it is yes, go and update it. If it is no, correct, reject the update. So that means that an earlier statement was like go and update the last. If the last update, if the last read record is same, then go and update that record. Is what is meaning here. So current version that is still in 5. So that means still it's not modified. The
no, I'm
last
not asking for this flow
ah,
chart. I understand you understand this.
ah,
Means for you can say user perspective, think
Ah,
about a user perspective.
okay,
How user will understand this and how he will memorize this version is 5 or 10. How? I I want you will think from a user perspective. You
okay.
need to think as a user perspective and tell me this flow is clear to you or not.
Okay, with the example of an item only, we will take a product. He places an order. No, first he is scrolling the items. Then he saw one particular item which he wanted. The current stock, sorry, it is showing 10. So let's say there's a delay of 1 second. He clicks on the order button. He wants to order. So again, if it shows 10, then that means okay, whatever he has seen, and when he's about to place the order, so far nobody has bought that item. Whatever quantity he wanted, 10 is still been shown. So he's able to see 10. Then he places the number of quantity. For example, he's able to place one order. He'll select item, then quantity as 1. And then when he clicks all the other things, the checkout, when he says payment of that, then the stock gets updated, detected by 1. So in the display screen, what quantity he saw, and the same quantity, if it is there while he's placing the order, then there is a consistency, and then uh, okay, currency, 1 minute.
You simply check this. They already know the means previous version. Okay, they have version with them. They have a version with them,
Ah,
and while requesting for updating the thing, they will send a version number
ah,
in a request with the
okay,
means the updated data what they require.
ah,
Okay, and our system will match check this version is there. If version is there, then whatever data they send for update, it will update.
hmm,
If version is not there, that means it's already updated.
ah,
Then it will reject the thing.
oh, okay, okay,
This is the only thing this flowchart is explained.
oh, okay, okay, okay.
So
No,
I means my gut feeling saying Sridhar not understand this clearly. That's why I asked this question.
ah, no, but I'll tell you, Deepak, here that version is causing the little confusion now. But can I say that what you meant by version was the last red, for example, I'm using the quantity called quantity I'm using. Okay. So the last red quantity was 5, correct? The last red quantity was 5. The client, the end user is modifying, is placing the order, and then that last red quantity is still 5. So it will go on update that quantity from 5 to 4. Is that correct explanation?
No, but quantity is a one property. We are considering a whole object.
Oh, that's a difference. Okay, okay, okay.
You understand my point?
Okay, okay, okay.
Like you are talking about a one part
Yes,
only.
one part.
I am talking about a system or
Oh, okay.
whole object. You understand?
Oh,
Let's
okay,
say
okay.
earlier user means user changed the name only
Ha, 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 ha.
or company name only.
Ah, 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 ah,
That's a change. Am I
ah,
right?
ah, ah.
Then should be only one single source of truth. With the help of that, we can identify it's changed or not.
Oh, okay. Okay, now I got it. Okay, so version is that. Okay. Okay, I was talking only about the quantity. Here you're talking whole as an object. Any part of the object is modified, right? So,
Yes.
okay, okay. Oh, beautiful. Okay, this I see. I never thought of this. I never ever thought. Always I was thinking only with respect to the quantity, stock, price. But okay, fine, right.
Means means my gut feeling is,
Correct.
Miss warn me, Sridhar not clear about this point.
Ah,
So I need to ask a question.
right, right. Beautiful.
Okay.
Right.
So now passive, earlier we will go for optimistic,
Now,
now pessimistic looking. What do you
okay.
understand from pessimistic looking? Pessimistic and looking, what do you understand?
Okay. General meaning of pessimistic is um, thinking negative or saying not possible, pessimistic. But now, with respect to that, here how it is linked to locking or pessimistic locking. I'm sorry, let me read that. Pessimistic locking prevents concurrent updates by locking the resource before. Okay, 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 okay. 1 minute. I'll try to give a very good example of what I think. Um, okay. Uh, See, this I have experienced, Deepak. Give me just a minute, just 1 minute.
But I want your reasoning. Okay.
Deepak, no, I'll tell you because this problem I faced in my own office. I'll tell you where it is.
Okay.
See now, if you take there was a HR module. Okay, so people like all the new joinees details are entered. So there were two people in HR department. So let us say now one person is trying to update the name of the employee. Let's say the person comes and says that there's a change of my name. Some spelling mistake is there. You please rectify it. So what I do, I go and search for that employee number, and the details I get the details are popped up on the screen, and that guy is modifying. The name is changing. User B is sitting in some other cabin. Now he wants to update the salary. Initially, they gave salary of example, say 10,000. Now they want to change the 10,000 to say 11,000. So he wants to modify the salary as 11,000. This guy is trying in other cabin, one guy is trying to modify the username. The other guy is trying to modify the salary part of it. So now user A, he gets the first access to the record. He is the first person to get the access of that particular record. So now, till he completes the modification of the name, user B won't be able to modify the salary. It will say the record is locked because this guy is trying to modify the name. And that guy, for a fraction of a second, there's a delay in he accessing that record. Yes, for user B, he will see the record as it is. User A is still updating the name, still he has not saved it. So user B will see still the old name and old salary. But when he's trying to modify, system won't allow because this guy has already locked that record. Till he clicks save button or cancels the whole operation, user B won't be able to do any operation. You'll see still all the old record structure intact.
Yes. So basically, you have a one, you can say, box, and in that box, you want only one person can use at a time.
Yes.
Okay.
Yes.
And whomever you will want to access, you will provide a key.
Correct.
Box is locked there. Am I right?
Lock. Yes.
Okay, if someone want to use, we will means give a key, and that can use
Yes.
whomever have a key.
Yes.
Another person need to wait. Okay.
Yes.
If means when they done, they will return back the key to you.
Key to them. Yes.
Then another person, whoever in a queue, then will
Yes.
get a key and use that.
Yes. Yes.
So this is simple. Am
Yeah.
I right?
Yes.
In this manner,
Yeah.
means this is a we need to proceed. And now idempotency concept, which we
Uh-huh.
discussed so many times.
Yes,
Right.
correct, correct, correct.
Okay. Now tell me what is that?
Like I mean, the same coming to online boutique, the same user cannot place the order twice in the same moment. He can't, for example, a payment. Even if he double clicks on the payment, there should be only one transaction. It should not do a double payment. It should do only once, one payment only. Even if he clicks many times, there should be only one payment transaction for that order. So it should not allow more than one. So that is idempotency. See here, theoretically only I know, but practically how to implement it, how it works, I don't know, Deepak. Probably in this course, I think I want to really do that.
Okay.
So idempotent ensures that repeated request produce the same final effect as a single request. Ah, right. Okay. Okay.
Okay. So we need to, earlier we also discussed this so many times.
Ah,
So how you will validate, how you will do that. So
ah,
means you need to, when someone is try, you need to check the status.
ah.
Before doing any operation, you need
Mm,
to check. Makes
mm.
sense. Let's say you are going for a updation,
Ah,
and updation you need to have something. If
mm,
user is sending this, then you need to validate. Am I
ah,
right?
ah, ah.
Or whatever uniqueness is there, you need to
Mm,
validate. Is
ah,
there or not? Am I right?
mm.
And they means whatever we discussed earlier,
Mm,
based on that you can avoid that.
ah,
Let's say there is a right operation is there,
ah,
and you are blindly doing
ah,
that.
ah,
Blindly, that
ah.
means whatever is there, you are just validating and doing that. No,
Mm.
you need to check that is
Okay.
the timestamp or based on another parameter. You need to check and validate. Is there
Okay.
or not? Is there or not?
Okay. Okay.
Okay.
Okay.
So using this kind of thing, you can avoid
Oh,
and achieve this adaptancy concept. Okay.
oh, okay. Okay.
So this is how you can say this.
Mm.
So here you are able to see they will give us a key for
Ah,
that
ah,
particular request.
okay.
And that key is, you can say, transition from one step to another, one step to another. Am I right? Key should be there. So
Right.
whenever user is requesting, it's sending that key.
Ah.
Okay, for each and every step. So
Mm,
based on that, we will check the status of our request, and if the status is there, then we can say, hey, this is already done.
mm.
Okay, and key already seen, yes, return previous result. Okay, if it's
Mm.
not there, process
Mm.
further. You understand my point?
Okay. Return previous result. No, okay. Process the payment. Okay. Show result against the key. Return to success. Okay. Right.
Okay, now you understand how you can implement this.
Okay, yeah, it's okay. Yes.
Tell me how you will implement in your boutique app.
Okay. The moment an order is placed, okay, order is placed. The moment he clicks on payment, then I need to generate a unique key and then hold that key, and then once the payment is processed, then against that key you just say it's payment is done. For example, done. If for some reason, if for network reason or some reason payment is not done, then just say no and hold it there. Then so again, for example, again say he's retrying it, the same key, because that key is still not having the value as of done. So using the same key again, attempt the payment services. Then finally, the moment it is a success, you mark it as done and then come out of it. So that means for whatever payment initiation has been done, that will have a unique key. That key will get, I mean, its work will be done only when the payment is done. Otherwise, that key is still active. So in that way, we are ensuring that double payments are not made, and this covers the concept of idempotency.
Yes, you can understand. If payment is, you can say, done, it should be completed.
Complete, yes, yes.
If it's not there, then it should be a, you can say, acid rule is there. Am I right?
Ah, 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 ah,
So based on that, it's completely done, or
ah,
otherwise it's rollback.
completely rolled back. Okay, yes.
Yes, if it's a rollback, then key is not there. Am
Ah,
I
ah,
right?
yes.
And you will not get anything based on
Yes,
that key.
correct, correct, correct.
You understand my point?
Right,
So
right,
these
right.
are the techniques which you can use.
Ah, ah,
Okay.
ah.
So now you can check this without adaptancy and versus with adaptancy.
Oh, okay. So, fine. Retry request, charge again, duplicate payment. Now, retry request, check idempotency, return existing payment result. Fine. Okay. Right. Okay.
So now this is the most important aspect
Mm, mm,
which you need to understand here.
mm, 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 mm,
So distributor system trade-offs.
mm,
Why trade-offs are there
mm, mm,
in
mm.
distributed system? What you are thinking regarding this? Why so many trade-offs are there?
Balancing assistance, availability, latency, throughput, and complexity. Distributed systems. Okay. What's the distributed system now? So, yeah. See, today, as everything is in the cloud, the entire data is distributed across the regions and the countries. So, the same data, what I'm able to see in, for example, in my region, uh, everybody else in their respective regions, they have to see the same data. I cannot see something different. They cannot see something different. So there, across the regions, the consistency has to be maintained. Even availability, yes, that is nothing but your stock details. If I'm seeing one particular item quantity as 10, everybody should be able to see the same quantity as 10. Then latency, yeah, here, let us say now my servers are placed in a Bangalore region. I am a Bangalore user. So for me, let's say now it will take 5 microseconds to bring the data. Whereas for user who is in say Canada or Australia, he may there may be a slight delay. For example, I'm saying 5 microseconds. He may see the product in say 8 microseconds or 7 microseconds. There's a very small latency because locally for me the network traversing is time is reduced, so it's almost instantly it will come. But he may see a very negligible but still a small delay in bringing up the data. That is the latency when it comes to the distributed system. And same, the throughput is not the same. The amount of work done in a unit of time. So there will be a small delay.
Hold on, hold on.
Yes.
My question, let me rephrase my question again.
Okay.
There is a distributed system is there, and another one is a, you can say, centralized system. Am I
Ah,
right?
ah.
So why trade-offs are more in a distributed system? My question is this, as compared to central. Why?
Okay. Distributed system trade-offs. See, in case of a centralized system, let's say you have one server which is serving to many clients. So, any updates, any change, all that I do only in one place. That is in a centralized location. One server, example, one server I go and do, and it will get reflected to all the clients. In case of distributed system, the servers are spread across. So there, I have to do some extra, I don't know what to say, extra work covered, but ensure that across the regions, you do the updates so that everybody sees the same data, is what I can think of distributed versus the centralized.
So definitely, your team is sitting in a single office. You can communicate well, am I right?
Easily.
And with the easy, you can do that. But you can say your team is sitting in a different offices, am I right? And if you want, you have a, you can say this meeting in a main office, am I right? And you called a meeting in a main office, then there are trade-offs are there. Some person may be delayed, reach with the reached late there, am I right? Some people are maybe not able to join. So same thing with this distributor system. Makes sense. Because there is a lot of things we need to consider.
Okay.
You understand my point?
Okay.
So for that, that's why each and everything we need to think about a trade-off. If you want this, then this will go down.
Okay.
If you want this up, then this will go down.
Okay.
Understand my point?
Okay.
In that manner, you have a better, you can say, control. You need to increase, cost is increasing there.
Yes.
You understand my point?
Correct. Yes.
So you can say to achieve this latency, availability, consistency, complexity. Am I right?
Okay.
So you will do that, but if you go for complexity, harder engineering.
Yes.
Trade-off, safer correctness. Am I right?
Yes, correct.
You understand my point?
Right.
So you need to think
Right.
about these. Okay. Because as we discussed earlier, we need to think about a failure as well.
Yes.
So we need to think that as well.
Correct.
Okay. These are some principles which we need to take care while thinking interfaces or API design.
Okay.
We need to don't think always, you can say this stable and thing. You need to think of business. What is the role of the business there?
Okay. No, I am more towards stable. I have to shift my thinking.
Okay. And how means what are the steps means during that process? And what are the, you can say, we will identify this has been updated. Understand my point?
Right.
And as we discussed, we need to, if something is failed, we need to check means how it will retry, how many time it will retry.
Yeah, correct.
And it need to be take care of idempotency. So those things also need to be considered.
Right.
Okay.
Right.
Whatever we discussed earlier, conditional right, versioning or locking, you need to think that as well.
Right.
So separate critical, what is non-critical, you can think that so that we can, based on that, we can take a decision.
Correct.
Okay.
Right.
So this is a good API design API boundary design.
Okay. So client app, API layer, payment services, okay, payment service, order service, and tracking service. Okay, three services are there. And oh, separate, okay, payment DB, order DB, track. Okay, so don't keep everything in one. You just split across and then update only the required services. Okay, but the rest you not touch. Okay, so fine.
Why they done three different layers? Why?
No, no. One is like I'm distributing the load, and then one reason. The other reason is let's say tomorrow now for some reason my tracking services are down, but still my business will continue. My system will be up and running except for the tracking service. The rest of the things like the order placement, then payment services, all those things will continue working. My application won't be down. Only thing is my tracking is down. So that which I can fix it in the background without affecting my main application. I can continue doing business without any effect, without any problem. So my risk factors are largely reduced by putting these things separately, or what you say, if you're distributing the whole load instead of on a one entire system, you are distributing different services. Thereby, your risk is reduced, and you're taking care of the risks in a different way. You planned your risks very well, so that system is always up and running.
That's fine. What else?
Okay, so you're looking for one keyword, I think. No, I got it.
What
Uh,
else? Why we are doing that? This is fine. We will get a more control. And
huh,
if some one is disturbed, another one is working. Why?
okay.
Why we are require this separation? What are other advantage you can think of?
Okay. From maintenance point of view, it'll be very easy to handle. For example, let's say now I need to take backup of this every day.
Okay, I'm okay with that point.
Huh,
Tolerance point of view, failure point of view,
huh.
recovery point of view, scalability point of view.
Yes, yes.
Fine. Now I want to listen from you from user point of view.
Okay.
User point of view. What are the user you can think of, and what are the use cases you can think?
See, actually, the user is totally unaware of how many, I mean, these are all independent services. He's totally, for example, if you take an ordinary user who doesn't have any knowledge about
No,
computers.
no, 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 no. I'm talking about a distributor system, right? In a distributed system, you can think of any system, right? And you are also going to launch this boutique one
Ah, ah,
platform. Earlier, you are thinking it's a simple business. Now you are
yeah,
thinking as a platform.
correct, correct.
Am I right?
Yes,
So in that business, you have a distributed API. Am I right?
yes.
And you can say based on a rule rights there. Hey, user, this is a vendor and this is a delivery part. He need to know the this order
Ah,
detail only. He don't need to care about the payment and other.
mm.
You understand my point?
Yeah, yeah.
And the customer need to know the you can say this tracking only.
Yes,
You understand my point?
correct.
And means this kind of way you can think of you have a different user
Ah,
and you different user have a different requirement. So
okay.
that you can serve that better with a different counter.
Oh, okay.
From different counter, you will get a different thing.
Okay, okay.
You understand my point?
Okay, okay,
I
okay.
am trying to align, Sridhar, your this mindset with a normal thing.
Correct. Yes,
Okay,
yes.
that's why I'm asking this kind of question to
Okay,
you.
okay. I got it. I got it. Okay, fine. Okay.
Okay, right now you're just thinking high level and go in a flow only. But
Ha.
if I will say, hey, you need to change your flow, then it's difficult for you.
Yeah,
That's
difficult. Yes, yes,
that's
yes.
why I want you need to be trained in that manner. You can
Ah,
easily do that because in a if you go for interview and things, they will throw some question on you.
ah.
How you will handle that?
Correct.
Right,
Yes,
right
correct.
now we are doing in a you can say friendly manner.
Correct.
That time you will confuse. Am I right?
Yeah, correct.
Okay, go ahead, please.
Okay. Yeah, end-to-end food delivery example and end-to-end. Okay. Oh my God, oh, beautiful. Yeah, and user app. Okay, API gateway, order service. Okay, these are different services. Other payment service, restaurant service, directory service. Yeah, sorry. Delivery service, bank tracking service. Okay, fine. Create the order, then create order record, and then process payment. Then return back the status. Then start order. Mm, Pay, then send order to restaurant, right? Order accepted, come back and update it. Then again, assign delivery partner, yes, okay. It will go to the delivery partner, then one partner confirm, yes, okay, come and update it here. And then finally, show live tracking, okay, from the order to the end. Okay, so user app, API gateway, order service, payment service, restaurant service, delivery service touched, then finally the tracking service you're touching. Oh, probably it's a beautiful thing. The representation in a pictorial way is very beautiful.
Okay.
Yes, so nice. Okay.
Mistakes.
You ignore retries. Yes, correct. Very important, but we ignore it. Correct. No, okay. No idempotency for critical operations. Yes. Then concurrency control. Yes. No, that. Thank you. Then generic generic updatable, lose endpoint or low invalid state. Okay, fine. Okay. Then hiding consistency behavior. Okay, but clients cannot restore cannot reason about freshness or sanctity, safety. Okay, fine. Okay. Right. Processing again, duplicate side effects, corrupted business state. Okay, right. Okay. This I'll read and go through this. Okay, fine, right.
One line summary.
Okay, system interface and APIs are not just entry point to a system, they are control boundaries for correctness, safety, retrace, concurrency, and consistency. A distributed system. Good API design ensures that business workflows remain reliable even under failures, delays, and parallel updates. Wow. Okay.
Okay.
Right, Deepak. Beautiful. One way is you're trying to shift my thinking. That is beautiful because I always thought